Lesson NLP for phishing detection. Natural language processing is a crucial aspect of artificial intelligence that deals with the interaction between computers and humans using natural language. It plays a significant role in various cybersecurity applications, particularly in detecting phishing attempts. Phishing is a cybercrime where attackers pose as legitimate entities to deceive individuals into divulging sensitive information. With the increasing sophistication of phishing attacks, traditional detection methods often fall short. NLP offers a robust solution by analyzing and understanding the language used in phishing messages, enabling more accurate and timely detection. Phishing attacks are predominantly executed through emails or messages that mimic legitimate communication. The language used in these messages often contains subtle cues that can be detected through NLP techniques. One of the primary methods employed is text classification, where machine learning algorithms are trained to differentiate between phishing and legitimate messages. These algorithms leverage features such as word frequency, syntax, and semantic content to make predictions. For instance, a study by Sahan et al. Demonstrated that using NLP-based text classification models significantly improved the accuracy of phishing detection compared to traditional methods. Another vital technique in NLP for phishing detection is named entity recognition. NR is used to identify and categorize entities within a text, such as names, organizations, locations, and email addresses. This technique helps in recognizing the context and intent behind the message. For example, a phishing email might contain an urgent request from a supposedly well-known company. By identifying and cross-referencing the entities mentioned, NLP models can detect inconsistencies and flag the message as suspicious. According to a study by Barreno et al., incorporating NER into phishing detection systems resulted in a higher detection rate as it enabled the identification of deceptive content that would otherwise go unnoticed. Sentiment analysis is another powerful NLP tool used in phishing detection. This technique analyzes the emotional tone of the text to determine whether it contains elements of urgency, fear, or persuasion, which are common tactics used in phishing attacks. By evaluating the sentiment, NLP models can identify messages that are likely attempting to manipulate the recipient. Research by Bergholz et al. Highlighted that sentiment analysis significantly contributed to the early detection of phishing emails by identifying the psychological manipulation tactics employed by attackers. Machine learning models used in NLP for phishing detection require substantial data for training. These datasets typically consist of labeled examples of phishing and legitimate messages. One of the challenges in creating these datasets is the need for continuous updating to keep up with evolving phishing tactics. To address this, researchers often employ techniques such as transfer learning, where models trained on large general datasets are fine-tuned on smaller, specific datasets. This approach not only improves the model's accuracy, but also reduces the time and resources required for training. A study by Sachs and Berlin demonstrated the effectiveness of transfer learning in phishing detection, showing that models fine-tuned on domain-specific data achieved higher accuracy rates. The integration of NLP techniques with other cybersecurity measures enhances the overall effectiveness of phishing detection systems. For example, combining NLP with network analysis can provide a more comprehensive view of potential threats. Network analysis examines the relationships and interactions between different entities, such as email addresses and IP addresses, to identify suspicious patterns. When combined with NLP's ability to analyze the content of messages, this approach provides a more holistic solution to phishing detection. Research by Jagotic et al. Showed that integrating NLP and network analysis significantly improved the detection and prevention of phishing attacks, as it allowed for the identification of both content-based and network-based indicators of phishing. Despite the advancements in NLP for phishing detection, there are still challenges and limitations to be addressed. One of the primary challenges is the adversarial nature of phishing attacks. Attackers continuously adapt their tactics to bypass detection systems, making it essential for NLP models to evolve and stay ahead of these threats. Additionally, the diversity of languages and dialects poses a challenge, as NLP models need to be capable of understanding and analyzing messages in various linguistic contexts. To overcome these challenges, ongoing research and development are crucial, focusing on improving the adaptability and robustness of NLP models. Moreover, ethical considerations must be taken into account when developing and deploying NLP-based phishing detection systems. Ensuring the privacy and security of users' data is of utmost importance. Researchers and practitioners must adhere to ethical guidelines and regulations to protect individuals' sensitive information while leveraging NLP for cybersecurity purposes. Transparency in the development and implementation of these systems is also essential to build trust and ensure accountability. In conclusion, NLP offers a powerful and effective approach to phishing detection, leveraging techniques such as text classification, named entity recognition, sentiment analysis, and transfer learning. These methods enable the accurate identification of phishing attempts by analyzing the language and context of messages. The integration of NLP with other cybersecurity measures further enhances the overall effectiveness of phishing detection systems. However, ongoing research and development are necessary to address the challenges posed by the evolving nature of phishing attacks and to ensure the ethical and responsible use of NLP in cybersecurity. By continuing to advance and refine these techniques, we can better protect individuals and organizations from the growing threat of phishing.